Good morning, everybody. Good morning, Rahul. Yes, correct. A 3.6, B 2.4. So, good morning, students. Let's continue. I know. Yesterday, because of power cut, the class was cancelled. I know. Integral AX, that is AX square by 2 plus BX square, that is BX cube by 3. Between the limits 0 to 1 is equal to 1. Replace x by upper limit 1. Then it is a by 2 plus b by 3 is equal to 1. So in order to eliminate the denominator terms, multiply both sides by 6. Then it is 6a by 2, 3a, 6b by 3, that is 2b, is equal to 6 into 1, 6. So we did not get the values of A and B. So that's why let us use supporting equation, that is E of x is equal to 0.6. That is supporting equation, you can use that. So to get the values of A and B, we were given one more supporting equation, that is E of x is equal to 0.6. So E of x for continuous random variable, E of x formula I gave integral minus infinity to infinity x f of x dx is equal to 1. But the problem is defined in the interval 0 to 1 only. Problem defined in the interval 0 to 1. So that's why minus infinity to infinity will now from 0 to infinity x f of x dx is equal to 1. But f of x value is already given to be integral 0 to 1 f of x value a plus bx dx is equal to 1. So here x into a ax, next x into b. So this is ax plus bx square. Okay, let me check. We were given ax plus bx square of 5. Integral 0 to 1 x into f of x is ax plus bx square dx is equal to 0.6. I think we were given 5. So right side is 0.6. So this is 0.6. This is 0.6. Here it is also 0.6. So here x into ax, that is ax square, x into bx square, that is bx cube. So this is integration of ax square is ax cube by 3 plus bx cube integration bx power 4 by 4 between the limits 0 to 1 is equal to 0.6. So this is a by 3 plus b by 4 is equal to 0.6. To eliminate the denominator 3 and 4, multiply both sides by 12. 12a by 3, that is 4a. 12b by 4, that is 3b. 12 into 0.6, that is 7.2. Solve equations 1 and 2, you will get the values of a and b. From 1 and 2, we get a is equal to 3.6 and b is equal to minus 2.4 and b is equal to minus 2.4. So we got the values of a and b. Now you are asked to find variance. I will go to the next slide. To get variance, first of all, you need to find e of x square. Remember, e of x formula, integral x f of x. E of x formula, integral x f of x. E of x square formula, integral x square f of x dx. Integral x square f of x dx. Integral x square f of x dx. Next slide. So to find variance, you need to find e of x square, that is integral minus infinity to infinity x square f of x dx. So, but problem is defined only from 0 to 1. Outside this interval, f of x is given to be 0. So, in this interval, f of x is ax plus bx square dx. So, here x square into ax, that is ax cube, x square into bx square, bx power 4. So integral ax cube, that is ax power 4 by 4, plus bx power 4, that is bx power 5 by 5, between the limits 0 to 1. So this is a by 4 plus b by 5. A value 3.6 by 4, b value minus 2.4 by 5. Simplify this and tell me the value. Sum once again. So what is the value of e of x square? 0.42. Good. E of x square value 0.42. Substitute there. E of x square value 0.42. This is equal to 0.42. So now variance. Variance is v of x is equal to e of x square minus e of x whole square. E of x square is 0.42 minus e of x was already given to be 0.6 whole square. Simplify this. The answer should be 0.06. And listen to me, I want to add one more question, and all of you look here to the sixth problem itself. To the sixth problem itself, I am adding one more statement, that is find p of x less than 1 by 2. Please include to the sixth problem, I am adding fourth bit. That fourth bit is find p of x less than 1 by 2. Find p of x less than 1 by 2. So problem number 4, p of x less than 1 by 2. Remember, any number less than 1 by 2 should lie between minus infinity and 1 by 2. But the problem is defined in the interval 0 to 1 only. So any number less than 1 by 2 should lie between 0 and 1 by 2 only, because problem lies between 0 and 1. That's why any number less than 1 by 2 should lie between 0 and 1 by 2. And all of you please verify probability density function third condition. Probability density function third condition, p of a less than x less than b. Probability density function third condition, p of a less than x less than b, integral a to b f of x dx. So that is integral 0 to 1 by 2 f of x is ax plus bx square dx. I will go to the next slide. Next slide, or write one more step here. Ax integration ax square by 2, bx square integration bx cube by 3, between the limits 0 to 1 by 2. So replace x by upper limit 1 by 2. A into 1 by 2 whole square. Yes, you can solve using Muralidhar Reddy. You can solve if you want. And Naveen, E of x is integral x f of x. E of x square is integral x square f of x, but not f of x square. E of x cube is integral x cube f of x, but not f of x cube. Mean E of x, mean not E of x, mean is E of x, variance is E of x square minus E of x whole square. E of x square is integral x square f of x. Muralidhar Reddy, if you want, you can use cumulative distribution also. Now replace x by upper limit 1 by 2. So P of x less than 1 by 2. Yes, correct. No, 0 point. We'll see how much it is. Now replace x by upper limit 1 by 2, 1 by 2 whole square, 1 by 4, a by 4 divided by 2. So a into 1 by 2 whole square divided by 2 plus b into 1 by 2 whole cube divided by 3 plus b into 1 by 2 whole cube divided by 3. So a value 3.6, 1 by 2 into 1 by 2 whole square, that is 1 by 4, b value minus 2.4 minus 2.4 divided by 3, 1 by 2 whole cube, that is 1 by 8. So what is the answer? Is it 0.06? Even yesterday, sorry, what is the variance? Okay, fine. 1 minute. Variance 0.35. Variance 0.35 after simplification. And what is this value? 0.11 is correct. Variance 0.35 is correct. Variance 0.35 is correct. Cumulative distribution function is applicable both for continuous and discontinuous. So this is 0.06. Problem number 7. 0.06 is correct. So variance not 0.06. Variance 0.35. Variance 0.06. Let 1 minute. 0.42, 0.36. Yes, fine, correct. 0.06. And tell me this value now. Okay. 0.06. Variance correct. This is 0.35. Okay, fine. Okay. This is 0.35. Same model problem. Note down this and try yourself. Write down. Write down. First write down the density function of a random variable capital X is given by . f of x is equal to a plus bx 0 less than or equal to x less than or equal to 0, 0 otherwise. If e of x is equal to 7 by 6, then find problem number 1 a and b, problem number 2 okay, probability density function. See, probability mass function, practical example is probability mass function means mass of an object at some particular point. That is probability mass function. Probability density function means density function, density of some particular object in certain region, density of certain region. That is probability density function. You are finding probability mass function means so try this. The standard deviation I have already said in the last class. Note down, answer is first one, a is equal to b is equal to 1 by 4. Second one, 11 by 36. Don't raise the hands in the middle of the class. That is not suggestible also. Next slide. I know. I know. Problem number 8. A man draws. Please focus on that. Previous problem similar to the previous problem model only. Try yourself. Probability continuous random variable, probability density function should be used. Right. A man draws three balls from a jug containing 5 white balls and 7 black balls. He gets 20 rupees for each white ball and 10 rupees for each black ball. Full stop. What is his expectation. Option A 21.25 rupees. Option B 42.5 rupees. 42 rupees 50 paisa. Option C 31 rupees 25 paisa. Option D 45 rupees 21 paisa. It was given ISRO exam mechanical engineering 2017. Listen to me, everyone. A jug contains, everyone has to listen to me carefully. Jug contains 5 white balls and 7 black balls. A person selecting 3 balls from a jug containing 5 white, 7 black balls. For every white ball he has drawn, 20 rupees will be paid to him. For every black ball he has drawn, 10 rupees will be paid to him. Now, what is his expectation? What that guy is expecting, his expectation means, because he will be given some money when he draws a ball. Therefore, his expectation is some profit in terms of rupees, because by drawing a ball, he will be given money. So his expectation is some profit by just drawing the balls only. And listen to me, you have to define the random variable. Whatever you are asked to find, that is your random variable. What is his expectation means, what is his expected profit? What is his expected profit? Expected means E, profit means X. So let X is equal to profit amount. Profit amount won by the player. What is his expectation means, what is his expected profit in terms of rupees by drawing the balls. So that's why his expected profit, whatever you are asked to find, that would be the profit. That would be required to be found. Profit amount in rupees won by the profit amount in rupees won by the person. So profit amount won by the person. Here X, here P of X. And be careful, a person has drawn 3 balls. What's our possibilities? A person has drawn 3 balls, then 3 should be white, one possibility. 3 should be black, second possibility. 2 white, 1 black, third possibility. 1 white, 2 black. A person has drawn 3 balls. Possibility is 3 whites. Possibility is 3y. One minute, wait. So let us write the possibilities. 3 are white, 3 are black, 1 white and 2 black, 2 white and 1 black. Because X means profit amount. For every white ball, you will be given 20 rupees. If you draw 3 white balls, what is your X? X means profit. See, what is his expectation? Anonymous attendee, please listen to me carefully. Not expectation. Harsha, correct. What is his expectation means what is his expected profit? Expected means E, profit means X. So E of X we need to find. X means profit. So if you drop 3 white balls, what is the profit amount? 60 rupees. For every 1 white ball, 20 rupees. So probability of selecting 3 white balls. If you draw 3 black balls, profit amount 30 rupees. For each black ball, you will be given 10 rupees. 1 white, 20 rupees. 2 blacks, 2 tens. 20 rupees plus 20 rupees, 40 rupees. Option B correct, Sambhavi. And 2 white, 40 rupees. And 1 black, 10 rupees. 40 plus 10, 50 rupees. Now the probability of winning 60 rupees means probability of selecting 3 white balls. Probability of selecting 3 white balls. Probability of selecting 3 white balls is 5C3, total 12, 12C3. Probability of winning 30 rupees means probability of selecting 3 black balls. Total 7 black balls. Out of 7 black balls, 3 can be chosen in 7C3 by 12C3. Probability of winning 1 white and 2 black. Total 5 whites. Out of 5 whites, 1 can be chosen in 5C1 and 2 blacks. Total 7 blacks. Out of 7 blacks, 2 can be chosen in 7C2 by 12C3. So probability of winning 50 rupees means probability of winning 2 whites and 1 black. 2 whites and 1 black. Total 5 whites. Out of 5 whites, 2 can be chosen in 5C2. Total 7 black. Out of 7, 1 can be chosen in 7C1 by 10C3. Expectation. Expectation means E of X. Right now. Next slide. Expected means E, X means profit. So that is equal to 60 into 5C3 by 12C3. Don't use any formula, directly you write like this: 60 into 5C3 by 12C3 plus 30 into 7C3 by 12C3. 30 into 7C3 by 12C3 plus 40 into 5C1 into 7C2 by 12C3 plus 50 into 5C2 into 7C1. 50 into 5C2 into 7C1 by 12C3. Simplify this. Try yourself it later. As 2-3 students have already solved, it should be 42.50. Simplify later. Just note this and try yourself. Yes, Shambhavi Oza, your answer correct, and Harsha, your answer correct. A man with N keys wants to open a lock. He tries his keys at random. Expected number of attempts for his success is keys are to be replaced after every attempt. Option A n by 2, option B n, option C root n, option D none of these. Try yourself. Some problems you only have to try for your practice purpose to improve your skills. This problem given ISRO exam Electronics Engineering 2009. Harsha, what is the answer? Shambhavi, what is the answer? Should I give the answer? Teja, not option A. Option B correct. Option B correct. Option B correct. Try yourself. Not that. Option B is the right answer. Try yourself. We'll go to the next topic. Option B is the right answer. Option B. Next. Yes, N. Spurti N is the right answer. Next topic. N. Very good. Next topic. Heading. Main heading. Discrete probability distributions. And topic number 1, first discrete probability distribution is binomial distribution. Log n, f of x is log n. Where? Last slide, just 1 minute. Here random variable is discrete. This is root n by 2, n root n, not log n, none of these. Next slide. Right down. When do we use binomial distribution? Remember, in generally in any exam, they will not mention to solve one problem using binomial distribution. You only have to decide whether one problem should be solved or not using binomial distribution. Condition number 1, number of trials must be finite. First listen to me, still previous slide. Very good. Condition number 1, number of trials must be finite. Means experiment should be conducted finite number of times only. Finite number of times only. Condition number 2, there are only 2 possible outcomes called as success and failure. There are only 2 possible outcomes called as success and failure. Success means occurrence of one particular event. Failure means non-occurrence of same particular event. Suppose you want to find out probability of occurrence of head by tossing a coin, then occurrence of head will be success, non-occurrence of head will be failure. Non-occurrence of head will be failure. And condition number 3, probability of success in each trial is constant. Probability of success in each trial is constant means if success means occurrence of an event. So probability of occurrence of an event in each trial is constant, means same. Suppose a coin is tossed, probability of occurrence of head is 1 by 2. Coin tossed second time, probability of occurrence of head is 1 by 2. Coin tossed third time, probability of occurrence of head is 1 by 2. That means probability of occurrence of an event in each and every trial is same. Same means constant. This is condition number 3. Condition number 4, all trials are finite. Sorry, all trials are independent. All number of trials are independent. Each and every trial is an independent trial only. So any problem satisfies these 4 conditions, solve that problem using binomial distribution. Even one condition not satisfied, don't use binomial distribution. So write the notes. I'll just come in 1 minute. I know. Condition number 1. number of trials should be finite. Number of trials finite means experiment will be conducted finite number of trials only. Condition number 2, there are only two possible outcomes called as there are only two possible outcomes called as success and failure. Success means occurrence of an event, failure means non-occurrence of an event. So probability of success in each trial is constant. Means probability of occurrence of an event, success means occurrence of an event, failure means non-occurrence of an event. So probability of occurrence of an event in each and every trial is same. A die is thrown first time, probability of occurrence of 1 is 1 by 6. Die thrown second time, probability of success means probability of occurrence of numbers 6 is 1 by 6 or number 1 is 1 by 6. All trials are independent. All trials are independent. If these four conditions are satisfied, that problem should be solved using binomial distribution. Next slide. Going to the next slide. So when do we use binomial distribution? If these four conditions are satisfied, then to find the probability of occurrence of an event x times if an experiment is repeated n times. To find the probability of occurrence of an event x times if the same experiment is repeated again and again and again n times, then binomial distribution should be used provided these four conditions are satisfied. Definition. Right now. The probability mass function of the binomial distribution See here, all trials are independent means first one die is thrown. That is one trial. Its sample space different. Second time another die is thrown. Then 1, 2, 3, 4, 5, 6. Its sample space is different. Sample space different only. We have all trials are independent. Here we consider one sample space. We are not considering one sample space. Please try to understand. We have discrete probability distributions as well as continuous probability distributions. I am writing very slow. You are writing very slower than me. Sample spaces different. One trial, one sample space is given by Nodo. P of x is equal to ncx into p power x into q power n minus x, where x is equal to 1, 2, 3, 4, so on, n, and q is equal to 1 minus p. Probability of success is constant means this is the fourth time I am explaining. Suppose a coin is tossed, probability of occurrence of head is a success. Coin tossed first time. So probability of head is 1 by 2. Coin tossed second time. Probability of head is 1 by 2. So probability of success means probability of occurrence of head in each and every trial is same. That is constant only. Write down where n is equal to number of trials, t is equal to probability of success. Success means occurrence of an event. Q is equal to probability of failure. X is equal to number of successes. X is equal to number of successes. If you can focus on what I am teaching here, definitely doubts will not be arised. The only thing is while I am teaching, if you concentrate somewhere or typing the questions, then only the doubts will be arised. If you can follow me step by step, doubts will never be arised. Generally, rarely may be arised, but frequently you are not getting. Here what I said, I have clearly explained probability of if whenever you wish to find out probability of occurrence of an event x at times, if one particular experiment is repeated again and again and again n times, then only we can use binomial distribution by satisfying these conditions. So here x means number of successes, n means number of trials. Number of trials means if an experiment conducted n times, one particular event occurs x times. Suppose a coin is tossed 10 times, heads occur 5 times only, heads occur 5 times, so x is equal to 5. X is equal to 5. This is the definition. Note. Follow me step by step. Note first point. Mean of the binomial distribution is NP. Variance of the binomial distribution is NPQ. Next slide. Going to the next slide. Standard deviation. Standard deviation means root of variance, that is root of MPQ. Fourth one, everyone should remember, mean of the binomial distribution is always greater than its variance. Mean of the binomial distribution, lot of time was given. Again, you are asking previous slide. At last, if you want, I can show you all the slides. It is not, anything is not predefined. So actually, Harsha, do you know variance formula E of x square minus E of x whole square? By applying that formula, we can derive. It's a formula. It is not predefined. It is not formula. We can derive. It's a theorem statement. Mean of the binomial distribution is always greater than its variance. Binomial distribution mean NP, variance NPQ. So NP okay, NPQ. Q can be written as 1 minus P. NP into 1, NP minus NP into P, NP square. So it is obvious, NP is always bigger than NP minus something. NP is always bigger than NP minus something. That's why mean of the binomial distribution is always bigger than its variance. Problems? Right now? Previous problem. Is it not binomial distribution? Which problem? Previous problem? Man with n case. See, binomial distribution should be used whenever you are asked to find the probability of occurrence of one particular event if the same experiment repeated n times plus the extra 4 conditions are to be satisfied. Plus the extra 4 conditions are to be satisfied. Extra 4 conditions are to be satisfied in problem number 8. If it's satisfied, we can apply. Problem number 8. But 4 conditions are satisfied or not satisfied. How can you apply? My humble request to everybody, first instead of typing here, first you remember the answers what I gave. Conditions you have to remember. Write down. Focus on problems, not problem number 9, not binomial. 4 conditions in problem number 9, you are not asked to find the probability of x successes out of n trials. Number of trials n. but you are not asked to find the probability of occurrence of X successes. Write down. Problem number 1. Over a large set of inputs, a program runs twice as often as it aborts. Full stop. The probability that of the next 6 attempts of the next 6 attempts four or more will run. 4 or more will run is dash. Remember, over a large set of inputs, probability of a program running is equal to 2 times of probability of a program aborts. Aborts means fails. So we were given probability of program running plus probability of program aborts is 1, because sum of the probabilities is always 1. Probability of program running plus probability of program aborts is 1. But in the problem they mentioned probability of a program runs is 2 times of probability of a program aborts plus probability of a program aborts is 1. We were given probability of a program running successfully is equal to probability of a program fails. It was given already. So 2 times of probability of aborts plus 1 time of probability of aborts, that is 3 times of probability of a program aborts is equal to 1. Probability of a program aborts is equal to 1 by 3. Moreover, probability of program running is equal to 2 times. Sorry, here 2 times probability of a program running is equal to 2 times of probability of a program fails. So probability of program runs is equal to probability of program runs is equal to 2 into probability of program aborts. 2 into probability of a program aborts. So this is okay. And moreover, listen to me, when do we use binomial distribution? Condition number 1, experiment conducted finite number of times only. In this problem, experiment conducted 6 times only. Condition number 1 fail. Sorry, condition number 1 okay. Condition number 2, there are only 2 possible outcomes, success and failure. Success means occurrence of an event. Failure means non-occurrence of an event. Occurrence of an event means program running successfully. Non-occurrence of an event, failure means program fails. Condition number 3, probability of success in each trial is same. Probability of success in each trial is same. That means probability of program running successfully, total 6 attempts. So probability of program running successfully in the first attempt is 1/6. Probability of a program running successfully in the first attempt is 2/3. Probability of a program running successfully in the second attempt is 2/3. Probability of a program running successfully in the third attempt is 2/3. In each and every attempt, probability of program running successfully is same, that is 2/3. Condition number 3 satisfied. If conditions 1, 2, 3 satisfied, by default 4th will also be satisfied. If these 4 conditions are satisfied, then whenever you wish to find the probability of occurrence of an event x times, if an experiment is repeated n times, then only binomial. Here the experiment is repeated answer 0.68 is correct. Answer 0.68 is correct. I will check. Mr. Anonymous Attendee, how can you solve this problem using binomial without using binomial? Tell me. So now total 6 attempts. Out of 6 attempts, p-value 2/3, p-value 2/3, q-value 1/3. P means probability of program running successfully. Just for our convenience, write down. You are asked to find the probability that out of 6 attempts, 4 or more attempts are successful. Out of 6 attempts, 4 or more attempts are successful. So that is P of x greater than or equal to 4. P of x greater than or equal to 4 means P of x is equal to 4. Please focus on teaching. If you continuously write on that, then your concentration will be diverted. Answer wrong. I am giving the answer. X greater than or equal to 4 means x is equal to 4, x is equal to 5, x is equal to 6. Because total 6 attempts only. Total 6 attempts only. That's why x greater than or equal to 4. I can take x4, x5, x6. What is the definition? Binomial distribution definition. P of x is equal to ncx p power x q power n minus x. So take x is equal to 4 in the definition. In the binomial distribution definition, nc4 p power 4 q power n minus 4. Take x is equal to 5 in the definition. nc5 p power 5 q power n minus 5. Take x is equal to 6 in the definition. nc6 p power 6 q power n minus 6. So n value 6. 6c4, p value 2 by 3 whole power 4, q value 1 by 3 whole power 6 minus 4, 6c5, 2 by 3 whole power 5, 1 by 3 whole power 6 minus 5, simplify this, you will get the answer 0.6068. Sorry, 0.68 will be the answer. Next. Write down. Problem number 2. P of x greater than or equal to 4 means x value 4 or 5 or 6. Total 6 cases. Write down. An unbiased die, an unbiased cubic die, with opposite faces, colored identically, and each face colored red, comma blue, or green, such that each color appears only two times on the die. Full stop. If the die is thrown thrice, The probability of obtaining red color on the top face of the die at least twice is what is the problem? Yes, correct. Harsha, correct. Look there. Unbiased die. Unbiased die means the chances of occurrences of 1, 2, 3, 4, 5, 6 are same. Means probability of 1 is 1 by 6. Probability of 2 is 1 by 6. 3 is 1 by 6. Probability of occurrences of each and every event must be same. 7 by 27 is the right answer. So probability of occurrence of an event in each and every trial is same. Now that type of die is thrown 3 times probability, and moreover that type of die was taken and it was 2 sides colored red, 2 sides colored blue, 2 sides colored green, such that each color appears only 2 times on the die. That type of die was taken and it was thrown 3 times. What is the probability of appearance of red color on the top face of the die? Whatever you are asked to find, based on that you need to define the random variable. What is the probability of obtaining red color? We need to find the probability of obtaining red color on the top face of the die. That's why assume x is equal to appearance of red color on the top face. 7 by 27 is the right answer. We can solve this problem using binomial distribution. Binomial distribution, reason you know. Look here, this type of die was thrown. You are asked to find the probability of appearance of red color. So appearance of red color, let it be P. P means probability of occurrence of red color in single trial only. In single trial only. That is 2 by 6. Probability of appearance of red color in one trial is 2 by 6. That is 1 by 3. So Q is equal to 1 minus P. Let me explain the question, man. If you continuously raising the hands, the concentration will be diverted. first focus on the question. Then continuity will not break. Continuously raising the hands, still you are raising the hand without concentrating on what I am teaching. Let me speak first. Q is equal to 1 minus P. 1 minus P means 1 minus 1 by 3. See, humble request, please don't raise the hand in the middle. I'll talk to everybody. Again asking. Q is equal to 1 minus P. 1 minus 1 by 3. Then N is equal to number of trials. The die was thrown 3 times. The die was thrown 3 times. This type of die was taken and it was thrown 3 times. And we were asked to find the probability of occurrence of red color on the top face of the die at least twice. Look there, we were asked to find the probability of occurrence of red color on the top face of the die at least 2 times. Red color occurs at least 2 times, means greater than or equal to 2 times. At least 2 times means greater than or equal to 2 times. At least means greater than or equal to. This I can write it as 1 minus P of x less than 2. 1 minus P of x less than 2. So this is any number less than 2, any number less than 2 should be either 0 or 1. Any number less than 2 should be either 0 or 1. So substitute. Next slide. Remember, P of x is equal to ncx p power x q power n minus x. And you need to find here P of x is equal to P is equal to, take x is equal to 0, P of x greater than or equal to 2. P of x greater than or equal to 2 is equal to 1 minus, take x is equal to 0 in the definition. nc0 p power 0 q power n minus 0. So take x is equal to 1. Substitute x is equal to 1 in the definition. Then it is nc1 p to the power of 1 q to the power of n minus 1. So n value 3. So that is 3c0. P value 1 by 3. Q value 2 by 3. N minus 0. P value, n value 3. P value 1. Q value 2 by 3. Whole power 3 minus 1. So 1 minus 3c0 1. 2 by 3, this is 2 by 3, 2 cube, 8, 8 by 27, 3c1, 3, 1 by 3, that is 2 square, 4, by 3 square, 9. So this is equal to 1 minus 8 by 27 plus 12 by 27, that is 1 minus 20 by 27, that is 7 by 27. Next slide. Next slide. Note this and try yourself. A test has 5 multiple choice questions and each question has four answer options A, B, C, D. What is the probability that a student will choose B? For at least 3 questions. If he or she leaves no questions blank. P of x greater in the previous problem, P of x greater than or equal to 2 means P of x is equal to 2 plus P of x is equal to 3. Like that also you can solve, no issue. Try this later. Problem number 4. Write down. A fair die option secret. A fair die is rolled 3 times. Stop. Given that six appeared at least once, the conditional probability that six appeared remember a die, fairy die means unbiased die. A die is thrown 3 times. Suppose 6 appeared at least one time. What is the conditional probability that 6 appeared exactly 2 times? Okay. This problem belongs to occurrence of 6, number of times occurrence of 6. So that's why first to define the random variable. This problem belongs to occurrence of 6, number of times occurrence of 6. So that's why let x is equal to I am giving enough time to copy. You are taking lot of time. So this problem belongs to occurrence of 6. Therefore, P is equal to the die was thrown 3 times. So N is equal to 3. P means probability of occurrence of number 6. That is 1 by 6. Q means 1 minus 1 by 6. That is 5 by 6. You are asked to find, be careful what I am saying. Given that 6 appeared at least one time, what is the conditional probability that 6 appeared exactly 2 times? Already known event is 6 appeared at least one time. Unknown event is 6 appeared exactly 2 times. Unknown event is 6 appeared exactly 2 times. Known event is 6 appeared exactly 1 time. Known event right side of this vertical line, unknown event left side of the vertical line. Probability of A given B. Formula, probability of A intersection B by probability of B. Here A means x is equal to 2, B means x greater than or equal to 1. So this is probability of A intersection B by probability of B. And look there, everyone, and look here, x greater than or equal to 2. X greater than or equal to 1 means what? X is equal to 1, 2, 3, so on. And x is equal to 2. X is equal to 2 means x is equal to 2. You only tell me x greater than or equal to 2, x greater than or equal to 1, intersection x is equal to 2. In these two, common events are x is equal to 2 only, no? X greater than or equal to 1 and x is equal to 2. In those two, greater than or equal to 1 means 1, 2, 3, 4, 5, so on. X is equal to 2. So common events of x greater than or equal to 1 and x is equal to 2 will be x is equal to 2 only. So denominator p of x greater than or equal to 1, also written as 1 minus p of x less than 1, that is equal to p of x is equal to 2, 1 minus p of x less than 1. Less than 1 means 0. Don't write minus symbol. Less than 1 means 0 only. Because if you write x is equal to minus 1, 6 occurs minus 1 times, minus 2 times, practically not possible. Answer 0.16 is correct. Abhijit, your answer is correct. 0.16 is correct. Now we need to simplify. We have to simplify. Proceed. Substitute x is equal to 2 in the definition. Then it is nc2 p power 2 q power n minus 2. Take x is equal to 0 in the definition. nc0 p power 0 q power n minus 0. N value 3. 3c2. P value 1 by 6. So 1 by 6 whole square, Q value 5 by 6 whole power 3 minus 2, 1 by 1 minus n value 3, C0, P value 1 by 6 whole power 0, Q value 5 by 6 whole power 3 minus 0. Answer after simplification 0.1648. Simplify and try yourself. Note this problem. Note this problem and try yourself. A random variable okay na? Again previous slide. I know. a random variable capital X follows binomial distribution with mean is equal to 2 into variance and the mean plus variance is equal to 3. Next slide. Next. A certain type of missile with probability 0.3. Problem without replacement. With or without replacement, no issue. It has to fulfill binomial conditions. The minimum number of continuously you're asking previous slide. It is not good. Taking lot of time. Mr. Anonymous second, you are always taking lot of time. The minimum number of missiles that should be fired so that probability of hitting the target at least once is greater than I will go to the next slide. Next slide. Next slide. Poisson distribution. So when do we use Poisson distribution? Listen to me, 99% in the examination, they will mention to solve one problem using Poisson distribution. In case they do not mention in the exam to solve one problem using Poisson distribution, you can still solve that problem using Poisson distribution if it satisfies these conditions. Remember, number of trials are very large. Number of trials are very large. Means experiment will be conducted large number of times. Number of trials are very large. And probability of occurrence of an event is very small. Experiment is conducted large number of times, but probability of occurrence of one particular event is very near to zero, but not zero. That problem should be solved using Poisson distribution. That problem should be solved using Poisson distribution. For example, in a factory, a factory manufactures 1 crore bolts per 1 day. A factory manufactures 1 lakh bolts per day. And out of 1 lakh bolts, only 1000 bolts are defective. So probability of defective bolts is equal to 1000 by 1 lakh. So probability of occurrence of an event is very near to zero, but not zero. But number of trials are very large. So a company manufactures 1 lakh bolts per day. Out of 1 lakh bolts, only 100 bolts are defective. So probability of defective bolts is 100 bolts out of 1 lakh. That is very near to zero. That is the case of application of Poisson distribution. So write the definition. The probability mass function of sum. What is lambda here? Mean okay, but practically lambda means average or mean rate of occurrence of an event over the fixed time or fixed space. So lambda means average rate of occurrence of an event over the fixed time or fixed space. Average rate of occurrence of an event over the fixed time meant for average number of vehicles crossing the junction per every 1 hour. 1 hour is a fixed time. Average number of accidents occurring on a national highway per every 1 week. Average number of customers arriving at a bank per every 1 hour. Average number of telephone calls received by the telephone operator per every 1 hour. 1 hour is the fixed time. Fixed space means what? Fixed space means certain region. Average number of printing mistakes per every 1 page. 1 page will occupy some space. Yes, it is countable only. So average number of occurrences over average rate of occurrence of an event over the fixed time. So what I said in the last class, for every 1 hour, how many vehicles crossing the junction? But I did not say time interval 0 to 10. I did not say time interval 0 to, okay, you can say time interval 2 to 3. So how many vehicles crossing the junction per every 1 hour? So 10 vehicles crossing. For example, they are saying that they are clearly mentioning. Yesterday I said how many vehicles crossing the junction per every 1 hour. I did not mention. Here I am saying that per every 1 hour, 10 vehicles crossing, or per every 1 hour, 1000 vehicles crossing, or per every 1 hour, 500 phone calls received by the telephone operator. So here I am saying the number. If you don't know that number exactly, then it becomes continuous. So this is lambda. And what do you mean by here? Lambda value must be mentioned clearly. Average number of vehicles crossing the junction per every 1 hour is 100. Average number of printing mistakes per every 1 page is 5. That value I am mentioning. If they do not mention, that becomes contiguous. X is equal to, I will write in the next slide. X is equal to number of events or occurrences within Amal Bhargavan, listen to me. The only difference between binomial distribution, and Poisson distribution is in binomial distribution, number of trials finite. In Poisson distribution, number of trials are infinite. That is only the difference between them. Apart from that, rest of the things is fine. This. So I have defined what is lambda, what is x. I will write note. Note, first one, mean of the Poisson distribution is lambda. Poisson distribution is countably discrete random variable but countably infinite values. Variance V of x is equal to lambda. Standard deviation square root of variance. As we all know that mean and variance of the Poisson distribution must be same. Moreover, everyone please remember, whenever mean of the Poisson distribution is not given, then mean of the binomial distribution should be used. Reason, Poisson distribution formula has been derived from binomial distribution formula under the conditions number of trials n tends to infinity and the probability of occurrence of an event is very near to 0. Under these two conditions, Poisson distribution formula has been derived from binomial distribution formula. That's why whenever mean of the Poisson distribution not given, then mean of the binomial distribution should be used as mean of the Poisson distribution if these two conditions are fulfilled. That is, number of trials are very large and the probability of occurrence of an event is very small. Write down, if write down, if mean of Poisson distribution is not given, then the mean of binomial distribution should be used if number of trials are large, that is n tends to infinity. Theoretically n tends to infinity, practically n is very big number. N is practically like 1,000, 10,000, 20,000, 1 lakh, like that. Probability of occurrence of an event is very small. Remember, when do we use Poisson distribution? Number of trials are very large and the probability of occurrence of an event p-value very nearer to 0. Or generally in the exam they will mention to solve one problem using Poisson distribution. Whenever it is not mentioned to solve one problem using Poisson distribution, You can still solve that problem using Poisson distribution by using the condition of problem is related to average rate of occurrence of an event over the fixed time or fixed space. Your problem belongs to average rate of occurrence of an event over the fixed time or space. Average rate of occurrence of an event means average number of vehicles crossing the junction over the fixed time of 1 hour. Average number of telephone calls received by the telephone operator over the fixed time of 1 hour. Average number of printing mistakes occur per every one page over the fixed time of 1 hour. That is average rate of occurrence of an event. Break will be given. Why both are equal means what should I say? If you solve as per the procedure using the formula mean and variance of Poisson distribution, say problems. Problem number 1. Write down. Break will be given after this problem. Wait. $2,000 cashew nuts. Break will be given. Continuously don't type. 2,000 cashew nuts are thoroughly mixed in a flour. In a flour, not means flour. Flour means atta. 2,000 cashew nuts are thoroughly mixed in a flour. The entire mixture is divided into 1,000 equal parts. Small problem only, and each part is used to make a biscuit. Assume that no cashew nut is broken in the process a biscuit is picked at random. The probability that it contains at least one cashew nut is dash. Just 5 minutes. I'll give the break. It will take only 5 minutes. Listen to me, everyone. 2000. Actually, in this problem, they did not mention to solve one problem using Poisson distribution. In the examination, they must clearly mention to solve one problem using Poisson distribution. In case, even though they do not mention to solve one problem using Poisson distribution, you can still solve that problem using Poisson distribution, but your problem should be related to average rate of occurrence of an event over the fixed time. Average rate of occurrence of an event over the fixed time or fixed space. Here, 2000 cashew nuts are thoroughly mixed in a floor. So, the entire mixture has been divided into 1000 equal parts. Each part should be used to make one biscuit. 1000 equal parts, each part should be used to make one biscuit. 1000 equal parts are to be used to make 1000 biscuits. So, where these 1000 equal parts, where these 1000 equal parts containing how many cashew nuts? 1000 equal parts containing 2000 cashew nuts. 2000 cashew nuts are thoroughly mixed in a floor and that entire mixture is divided into 1000 equal parts. Therefore, these 2000 cashew nuts are gone into 1000 equal parts. Each part should be used one biscuit. 1000 equal parts, 1000 biscuits. So 1000 biscuits containing 2000 cashew nuts. So one biscuit containing how many cashew nuts? One biscuit containing how many cashew nuts? 1 by 1000 into 2000. One biscuit containing how many cashew nuts? 1 by 1000 into 2000. That is 2. 2 cashew nuts per biscuit. But your doubt is, sir, why you have taken it as lambda? So therefore, 2000 cashew nuts are in 1000 equal parts. 1000 biscuits containing 2000 cashew nuts. So one biscuit containing 2 cashew nuts. How can you say that exactly one biscuit containing 2000 cashew nuts? First biscuit 0 cashew nuts. Second biscuit 4 cashew nuts. Then how can we say that? So it is not exact number of cashew nuts per every one biscuit. Average number of cashew nuts per every one biscuit is 2. So lambda means average value of the Poisson distribution. Average number of cashew nuts per every one biscuit is 2 cashew nuts. So average means lambda. Here one biscuit will occupy certain space. One biscuit will occupy certain space. Therefore, average rate of occurrence of an event over the fixed time. Over the fixed time means over the fixed time or fixed space. Fixed space means the biscuit will occupy certain space. That is fixed space. For every fixed space, we have 2 cashew nuts are occupied. Therefore, this is the average rate of occurrence of an event over the fixed space. Space means one biscuit, how much space is it occupies, that much. Moreover, whatever you are asked to find, let it be x. You are asked to find actually one biscuit is picked at random. What is the probability that the picked biscuit will have at least one cashew nut? One biscuit selected at random. What is the probability that selected biscuit will have at least one cashew nut? So this problem is related to number of cashew nuts. So let x is equal to number of cashew nuts. Number of cashew nuts per one biscuit, because I have written average number of cashew nuts per one biscuit 2, not exact cashew nuts per one biscuit. Because you are asked to select one cashew nut, you are asked to select one cashew nut, one biscuit. What is the probability that there should be exactly one cashew nut per one biscuit? You are asked to find you are asked to find at least one cashew nut per biscuit. At least one. At least means greater than or equal to. At least means greater than or equal to. At least one means greater than or equal to 1. So we need to find p of x greater than or equal to 1. That is reverse. 1 minus p of x less than 1. That is equal to 1 minus p of less than 1 means 0. Less than 1 means 0. Don't write minus 1. If you write x is equal to minus 1, number of cashew nuts per one biscuit is minus 1 cashew nuts, practically not possible. So substitute x is equal to 0 in the definition. That is 1 minus lambda power 0 e power minus lambda by 0 factorial. So that is 1 minus e to the power of minus lambda. So after simplification, this value should be 0.865 approximately. We will continue after the break. Doubts at the end of the class we will discuss. We'll continue at the end of the doubts at the end of the session. After the break we'll discuss. We have break. Poisson distribution slide you want? Previous 2 slides only. Just 1 minute I will share the slides and we'll continue. Take a break. Poisson distribution, first slide. Poisson distribution, second slide. Poisson distribution, third slide. Break 10 minutes. Sagar, I will talk to you at the end of the class regarding your doubts. Slides starting from the beginning at the end of the session. In the Ojasvi, in the examination, they will mention to solve one problem using Poisson distribution 99.99%. Even though they do not mention, you can solve the problem using Poisson distribution in 2 cases. case 1, case 1, number of trials are very large. N value greater, n tends to infinity. Practically n great, n 100, 1000, 10,000 like that. Second, p value very nearer to 0, like 0.01, 0.02, 0.03 like that. Even though they do not mention to solve one problem using Poisson distribution, if these two conditions are satisfied, you can solve that problem using Poisson distribution. That is one case. Another case is problem is related to average rate of occurrence. Problem is related to average rate of occurrence. Look here. What is lambda here? Average rate of occurrence over the fixed time or space. Average rate of occurrence means average number of, in this example, problem is related to, belongs to average rate of occurrence, means problem belongs to average rate of, average number of cashew nuts per every one biscuit. Fixed space means some space. One biscuit will occupy some space. In that space, how many cashew nuts are allocated? Means average rate of occurrence of an event means average number of cashew nuts over the fixed space. Fixed space means one biscuit space. Then this lambda condition satisfied, solve that problem using Poisson distribution. At the end of the session, I'll give binomial loss slide. This is binomial loss slide. I'll continue after the break. If you have any doubts at the end of the session, we'll discuss. We'll continue at the end of the session regarding doubts. Welcome back. Right now, problem number 2. Problem number 2. If a random variable capital X has a Poisson distribution with mean 5, then the expectation equals dash. This problem given in the GATE Computer Science Engineering 2017. So here we were given mean. Mean is equal to 5. Means what? Mean of the Poisson distribution is lambda. So lambda is equal to 5. Moreover, mean and variance of Poisson distribution are same. Mean and variance of Poisson distribution are same. Therefore, variance is also 5. I'll do one thing. Mean of the Poisson distribution is also equal to variance of the Poisson distribution is equal to 5. So mean of the Poisson distribution is lambda. Lambda is equal to 5. Moreover, you are asked to find E of x plus 2 whole square is equal to e of x plus 2 whole square value, that is x square plus 4x plus 4. So I can write it as e of x square. Yesterday I gave the formula. In properties of mean and variance. One of that formula, e of ax plus b is a into e of x plus b. E of ax plus b, a into e of x plus b. This remaining part is e of ax plus b. Ax plus b means 4x plus 4. That is 4 into e of x. E of ax plus b is a into e of x plus b. Moreover, we know variance of x. Formula I gave already in the last class. That is e of x square minus e of x whole square. So from this, we just need e of x square. E of x square is equal to variance of x plus e of x whole square. So e of x square value, variance of x plus e of x whole square plus 4 into e of x plus 4. So in this statement of the problem, we were already given variance is 5 plus e of x. Okay, 1 minute. We all know that variance of the Poisson distribution is lambda. E of x is also lambda. 4 into e of x means mean. Mean of the Poisson distribution is lambda plus 4. Substitute there, lambda value 4. Lambda value 4 plus lambda square. 4 square plus 4 into lambda plus 4. 16, 16, 32. Where is the mistake? 1 minute. 1 minute. 1 minute. I will verify. I will check. I am checking, man. Why you are answering? Look here, v of x plus e of x whole square, v of x plus look there, this is e of x square plus 4 into e of x plus e of 4, that is 4. E of x square is variance of x plus e of x whole square plus 4 into e of x plus 4. So variance is 5. Variance is 5. E of x means mean. Mean also 5 plus 4 into e of x means mean. Mean also 5 plus 4. This is 20, 25, 45, 50, 54 is the answer. 54 is the answer. Next, problem number 2. Note down. On the average, on the average, 15 out of state cars pass a certain point on a road per hour. The probability that exactly 4 out of state cars pass that point in a 12-minute period is. In this problem, lambda problem is also related to average rate of occurrence of an event over the fixed time. Average rate of occurrence of an event means average number of vehicles crossing the junction over the fixed time of 1 hour in this example. They said per every 1 hour, 15 out of station cars passing a certain point on a road per every 15 hours, for every 1 hour. Now you are asked to find the probability that exactly 4 out of station cars passing through a particular point per every 12 minutes period only. For every 1 hour, 15 out of station cars passing a particular point on a road. But we were asked to find the probability that exactly 4 out of station cars passing a particular point per every 12 minutes period only. That's why we need to convert 1 hour problem into minutes problem. 1 hour means 60 minutes. 1 hour means 60 minutes. For every 60 minutes, 15 out of station cars passing a certain particular point. Now you are asked to, for every 12 minutes, how many out of station cars pass? For every 60 minutes, 15 cars will pass through a particular point on a national highway or on a road. Then per every 12 minutes, how many cars will pass? Then it should be 12 minutes by 60 minutes into 15 cars. That is 3. 3 cars per 12 minutes. This is not exact value. This is approximate value only. Because of first 12 minutes, 0 cars may pass. Next 12 minutes, 6 cars can pass. Therefore, in the first 12 and the next 12, on an average of 6 cars, on an average of 3 cars will pass. First 12 minutes, 0 cars. Next 12 minutes, 6 cars. So average 0 plus 6 by 2, that is 3. 3 cars per 12 minutes. This is average number of cars crossing a particular point per every 12 minutes is 3 cars only. So lambda value 3. Let us define random variable. You are asked to find the probability that exactly 4 out of station cars. How many cars passing a particular point per every 12 minutes? X is equal to number of out of state cars pass per 12 minutes. You are asked to find the probability that exactly 4 out of station cars will pass. So Poisson distribution formula, lambda power x e power minus lambda by x factorial. So take x is equal to 4, then it is lambda power 4 e power minus lambda by 4 factorial. But lambda value 3, so it should be 3 to the power of 4 e power minus lambda. Lambda is 3 by 4 factorial is 24. Then the answer should be 0.168. 0.168. Next problem. A telephone exchange receives an average of 180 calls per hour. The probability that it will receive only 2 calls in a given minute is dash. Next. .224, correct. Next slide. I don't. The probability of The probability of a resistor being defective is 0.02. There are 50 such resistors in a circuit. The probability of two or more defective resistors in this circuit try yourself it later, but I will give you the hint. Whenever mean and variance of Poisson distribution are not given, I mean mean of the Poisson distribution is not given, then mean of the binomial distribution should be used as mean of the Poisson distribution. But it has to satisfy two conditions. Condition number one, number of trials are very large. Means n tends to infinity theoretically, practically n is a big number. Even 50 also assumed as big number. And the probability value very, very nearer to 0. So here n is equal to means number of resistors in a circuit, that is 50. Next P is equal to 0.02. So number of trials are large and the probability is very, very nearer to 0. So mean of the Poisson distribution not given, then use mean of the binomial distribution as mean of the Poisson distribution. But sometimes they do not mention to solve one problem using Poisson distribution. You can still solve that problem using Poisson distribution if n tends to infinity and p tends to 0. Theoretically, practically n is a big number and p is very, very nearer to 0. So in this case, whenever the mean of the Poisson distribution is not given, then mean of the binomial distribution should be used as mean of the Poisson distribution. So Poisson distribution mean lambda. Binomial distribution mean NP. So n value 50, p value 0.02. Simplify this, you will get the answer 1. So therefore lambda value 1. Now we know lambda value, try yourself. You are asked to find the probability of two or more defective resistors. Means you need to find p of x greater than or equal to 2. You have to find x greater than or equal to 2. Answer 0.26, correct. Answer 0.26, correct. Try yourself it later. Up to 2 decimal places is fine. 0.26 is correct. Next slide. I am going to the next slide. See, but if you want, you can use binomial distribution also, no issue. But almost same answer only you get. But binomial distribution not suggestible for n is large. N binomial maximum 20 or 30 only, maximum 20 only. After that, if you want, you can use, but answers not that much reliable. Even you use binomial also, almost same answer you get. You may get 0.25, something like that you may get, no issue. But Poisson suggestible. Continuous probability distributions. The first one, normal distribution. It is also called Gaussian distribution. Remember, normal distribution, Gaussian distribution will have same meaning only. Write the definition. The probability density function of a random variable which is normally distributed with mean mu and variance sigma square is given by f of x is equal to 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. So that is minus infinity less than x less than infinity, minus infinity less than mu less than infinity, sigma greater than 0. Remember, mu is the mean and sigma square is the variance. This is the probability density function of the normal distribution. Next slide. Going to the next slide. Write down. This is the graph of normal distribution. So this is mu. This is f of x. This is the graph of normal distribution. This is 1 by sigma root 2 pi. The graph is 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square. Definition. This is only normal distribution. Next definition, standard normal distribution. Remember, in the normal distribution, this is the definition of normal distribution. In the definition of normal distribution, when you take mean mu is equal to 0 and variance sigma square is equal to 1, whatever you get, that is the probability density function of standard normal distribution. For example, in this normal distribution, don't write. If I take mean mu is equal to 0, mean mu is equal to 0, don't write, and variance sigma square is equal to 1, it would become 1 by sigma value 1, only root 2 pi e power minus 1 by 2 into x minus mu 0, sigma 1, x minus 0 by 1 whole square. So this is the 1 by root 2 pi into e power minus 1 by 2 into x square is the probability density function of standard normal distribution with mean mu 0 and variance sigma square is equal to 1. In the same definition of standard normal distribution, when you substitute mu is equal to 0 and sigma square is equal to 1, whatever you get, that is the probability density function of standard normal distribution. But just for the sake of our convenience only, already the previous definition was written in terms of x. Now let us write this definition in terms of z. Let us write this definition in terms of z. Just for the sake of variable difference only, I have written in terms of z. It is actually x only. So write the definition. Right. A random variable, capital Z, is said to have a standard normal distribution with mean mu is equal to 0 and variance sigma square is equal to 1. If its probability density function is given by, next slide, f of z is equal to 1 by root 2 pi e power minus 1 by 2 into z square, where z is any number lying between minus infinity and plus infinity. Random probability density function. The probability function of normal distribution is 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu by sigma whole square, where mu is the variance, sigma mu is the mean, sigma square is the variance. In the same normal distribution definition, when you substitute mu is equal to 0 and the sigma square variance 1, whatever you get, that is the probability density function of standard normal distribution. Here I said z is equal to x minus mu by sigma is called a standard normal random variable. I have already said z is the standard normal random variable. Any random variable that is subtracted from the mean and divided by the standard deviation, whatever you get, that is called standard normal random variable. As I told you already, standard normal random variable has mean 0 and variance 1. If you have a doubt, I will show you also roughly, you can cross check. Look there, z is equal to x minus mu by sigma, roughly. This is x by sigma minus mu by sigma, or E of z. E of z means what? E of x by sigma minus mu by sigma. That is 1 by sigma into E of x minus 1 by sigma into E of mu. So 1 by sigma into E of x. E of x is mean. Mean of the normal distribution is mu. And moreover, E of k, mu means mean. Mean is a constant term. So E of k is equal to k. E of k is equal to k value mu. So mu by sigma. So mu by sigma cancel, answer 0. I have already said mean of the standard normal distribution is 0. Here I said any random variable that is subtracted from mean and divided by the standard deviation, that is called standard normal random variable. So z is equal to x minus mu by sigma is a standard normal random variable. Standard normal random variable mean 0, variance 1. So z is equal to x minus mu by sigma. Mean of z means E of z. Mean of z means E of z. After simplifying that, we are getting 0. So in the same manner we can prove variance also. In the same manner we can prove variance is 1, but anyhow not required. Just remember that. Let us draw the diagram of standard normal random variable. The diagram of standard normal random variable, this. And look there in the previous diagram, this is in the previous diagram this is mu, this is mu. In this diagram, if I take x is equal to mu here, z is equal to mu minus mu, 0, 0 by sigma, 0. So z is equal to 0. In the previous diagram, look. Okay. This is the diagram. And moreover, in the previous diagram, I can represent like this also. This is mu minus sigma. Otherwise, it will represent in the next diagram. This is the diagram. Next slide. This is x is equal to mu, and this is x is equal to mu minus sigma. This is mu minus 2 sigma. This is minus 3 sigma. Similarly, here also the same gap you need to maintain because they may at equidistant. So this should be mu plus sigma, and it should be mu, sorry, this is mu minus sigma. Mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. This is mu minus sigma. This is mu minus 2 sigma. This is mu minus 3 sigma. Remember, area under the normal curve between mu minus sigma and mu plus sigma is 0.6827. That means if you can integrate this function, with respect to x between mu minus sigma and mu plus sigma, you will get the answer 0.6827. Similarly, area under the normal curve between mu minus 2 sigma and mu plus 2 sigma, this is, you will get the answer 0.9545. Similarly, area under the normal curve between mu minus 3 sigma and mu plus 3 sigma, we will get 0.9973. That means if you can integrate this function between mu minus 3 sigma and mu plus 3 sigma, definitely you get 0.9973. And look this diagram, and everyone has to remember the second diagram only. Now here mu, if you take mu is equal to x is equal to mu, here in the mu diagram z should be 0. Now here mu plus sigma. If you take x is equal to mu plus sigma here, mu plus sigma minus mu, sigma by sigma, that is 1. Sigma by sigma, that is 1. Similarly, here mu plus 2 sigma. If you take mu plus 2 sigma, mu plus 2 sigma minus mu, 2 sigma by sigma, 2. I will give that time. Let me complete first. So, area under the normal curve between -1 and +1 is 0.6827. Area under the normal curve between mu minus 2 sigma and mu plus 2 sigma, 0.9545. And similarly here also, area under the normal curve between mu minus 3 sigma and mu plus 3 sigma, that is 0.9973. So remember this diagram only, between -1 and +1, between -2 and +2, remember this diagram only. Use of normal distribution means any problem can be solved using normal distribution. So one random variable can be standardized if it is subtracted from mean and divided by standard deviation. Your random variable will be standardized. Even your gate score will be standardized. So your marks minus average marks divided by standard deviation of marks, then you will get a standardized gate score. Next slide. Remember, area under the normal curve between -1 and +1, 0.6827. Between -1 and 0, that is half of the area. Between 0 and 1 also half of the area. Area between -2 and +2, 0.9545. Between -2 and 0, half of the area. Between 0 and 2, half of 0.9545. Range of the normal distribution is -infinity to +infinity. Among this, I have already mentioned in the definition. Between this -infinity and +infinity, you will get the answer normal distribution range. First you draw this. Units of area are square units only. Actually, area, this is lying between -infinity and +infinity, but 99% area, 0.9973 means 99% area lies between mu minus 3 sigma and mu plus 3 sigma. 99% area lies between -3 and +3 only. Total area 1, 99% area between -3 and +3. That's why we need to consider. Next, note. Going to the next slide. Yes, area overtake means. Next slide. Note down. Total area under the normal curve is unity. Means total area under the normal curve is unity means 1. No, total area 1. Total area below the normal curve between -infinity and +infinity is 1. Total area between the -infinity and +infinity is 1. In this total area between -3 and +3, 0.9973 area will lie. The remaining 0.00 something will lie between -infinity to -3 and +3 to infinity. Right now. Total area under the normal curve is 1. Second point, right. See, normal distribution curve is a symmetrical curve. It is a symmetrical curve about x is equal to mu. Normal distribution curve is a symmetrical curve about x is equal to mu. Means same shape of the curve will exist on both sides of x is equal to mu. So that's why this total area must be split up into two parts. 0.5 area to the left side of mu and 0.5 area to the right side of mu. Because this curve is symmetrical about the line x is equal to mu. I know the area to the left of x is equal to mu is 0.5 and to the right of x is equal to mu is 0.5. Maximum value occurs at x is equal to mu. Look the diagram. Maximum value of the normal distribution occurring at x is equal to mu. This is the largest height of the curve from x-axis that occurs at mu. So maximum value occurs at mu. Next, points of inflection of a normal curve are mu minus sigma and mu plus sigma. Remember, point of inflection means at that point only curve will change its shape from concave up to concave down, or vice versa. The point at which curve changes its shape from concave up. This is concave up shape. This is concave down shape. So the point at which curve changes its shape from concave up to concave down, that is called inflection point or point of inflection. The points of inflection of a normal curve mu minus sigma and mu plus sigma. At x is equal to mu minus sigma and mu plus sigma, curve is changing its shape. At x is equal to mu minus sigma, curve is changing its shape from mu concave up to concave down. And at x is equal to mu plus sigma, curve is changing its shape from concave down to concave up. Therefore, mu minus sigma and mu plus sigma are inflection points. Points of inflection are inflection points. And do you know, if x and y are two independent normal random variables, then it's a linear combination c1x1 plus c2x2 plus so on cnxn is also a normal random variable only. Suppose x and y are random variables, then linear combination c1x plus c2y is also normal random variable. If x, y, z are independent normal random variables, then its linear combination c1x plus c2y plus c3z is also a normal random variable. Right there. If x1 comma x2 so on xn are independent normal random variables, then it's linear combination c1x1 plus c2x2 plus cnxn is also a normal random variable. Everyone have to by heart these formulas. These values will not be given in the examination. Means area under the normal curve between -1 and 1, between -2 and 2, between -3 and 3, you have to remember. In the exam they won't give. Other than that, anything is required that would be given in the exam. means area under the normal curve between 1 and 2.5, we don't know. That value will be given. These values, other than this, anything required will be given. Next slide. Problems. Let us not visible. Okay, na? Is this screen is visible? Is it visible? Okay. Remember, if x and y are independent normal random variables, then its linear combination C1x plus C2y is also a normal random variable. If x, y, and z are independent normal random variables, then its linear combination C1x plus C2y plus C3z also normal random variable only. I mean sum of two normal random variables is normal random variable. Difference of two normal random variables is normal random variable. But it is valid only x and y are independent normal random variables. X and y are independent. It is applicable to n number of variables. Next slide. Problems. Problem number 1. Write down a random variable capital X has normal distribution with mean 100. If p less than p, I mean probability of 100 less than x less than 120 is equal to 0.3. Then p of x less than 80 is dash. In the examination, it must be clearly mentioned the problem is a normal distribution. If they do not mention, how can you recognize that it belongs to normal distribution? In the exam, it will be clearly mentioned. It must be mentioned. It must be specified. Draw the graph. This is the graph of the normal distribution. And what is this? Mu. You are given mean of the normal distribution is 100. Mu means mean of the normal distribution only. This vertical line is x is equal to mu. Mu means mean. We were already given mean is 100. We were also given probability of 100 less than x less than 120 is equal to 0.3. And we just need to find probability of x less than 80. 120 should be 20 units to the right of 100. This is x is equal to 120. In this statement of the problem, it was clearly mentioned area under the normal curve between x is equal to 100 and x is equal to 120 is 0.3. So therefore it is 0.3. It is 0.3. As we discussed already, total area under the normal curve is 1. In this total area, 0.3 total area under the normal curve is 1. In this total area, 0.5 area will occupy to the right side of x is equal to mu, and 0.5 area will occupy to the left side of x is equal to mu. In this 0.5 area to the right side of x is equal to mu. But in this 0.5 area, already 0.3 area occupying between x is equal to 100 and x is equal to 120. So the remaining is 0.2 area. That 0.2 area should lie between x is equal to 120 and x is equal to infinity. The remaining 0.2 area should lie between x is equal to 120 and x is equal to infinity. Moreover, you are asked to find the probability of x less than 80. 80 means what? 20 units to the left side of 100. 80 means 20 units to the left side of 100. Moreover, they mentioned normal distribution curve is a symmetrical curve. Symmetrical curve means interval length same, area same. Interval length same, area same. Whatever the interval length between 100 and 120, same interval length was there between 80 and 100. So whatever the area between 100 and 120, same area will be there between 80 and 120, 80 and 100, just because of symmetry. Same area would be there. And we all know that total area to the right side, to the left side of x is equal to mu is 0.5. And already 0.3 area lying between 80 and 100. Therefore, the remaining 0.2 area will occupy to the left side of 80, that is 0.2. You are asked to find probability of x less than 80. X less than 80 means what? Area to the left side of x is equal to 80. X less than 80 means area will occupying to the left side of x is equal to 80. That is 0.2. Problem completed. Only from the diagram. Problem number 2. Write down. For a random variable capital X minus infinity less than x less than infinity, following normal distribution the mean is mu is equal to 100, p of x less than 80 means minus infinity to 80 only. minus infinity comma 80 only. Correct, Harsha? X less than 80 means total area to the left side of x is equal to 80. Total area to the left side of x is equal to 80 means minus infinity to 80. How much area was occupied? You need to consider. Mr. Anonymous attendee, if you say your name, that is better. Total area to the left side of x is equal to mu. C, continuous random variable. 80 included or excluded, no issue. For all continuous random variables, closed interval or open interval means including or excluding 80 or infinity, no issue. Answer will not change. Mr. Anonymous attendee, total area to the left side of x is equal to mu is 0.5. In that 0.5 area, already 0.3 area was there between 80 and 100. The remaining 0.2 will occupy to the left side of 80 only. Here the distance between 80 and 100, the distance between 100 and 120 is 0.3. Therefore, the distance between 80 and 100 also 0.3 because the both having same distance. That's why same area. Same I have considered. Right now. U is equal to 100. If the probability is P is equal to alpha for x greater than or equal to 110. Then the probability of x lying between 90 and 110, that is, I will go to the next slide. Next slide. Next slide. P of 90 less than or equal to x less than or equal to 110 will be equal to dash. It was given GATE Production Engineering 2007. Here answer 1 minus 2 alpha. 1 minus 2 alpha. I gave my number at the end of the class. I give today. Problem number 3. All of you note down problem number 3. Please focus on always previous side. If masses of (300) students are First to note the question, man, without writing why you are entering here. Today I will clarify all your doubts. 300 students are normally distributed. Let me complete. After completion, not raising hands now. With mean 68 kilograms. I will teach this problem. And the standard deviation 3 kilograms. Full stop. How many students have masses? How many students have masses? Problem number 1. Greater than 72 kilograms. Less than or equal to 64 kg. Between 65 and 71 kg. Both inclusive. Normal distribution table value will be given in the exam. Note. Area under normal curve between z is equal to 0 and z is equal to 1.33 is 0.4082. One small request to everybody. Okay, first you write. I will go to the next slide. Next slide. Write down. You are given mean of the normal distribution, that is 68 kilograms, and the standard deviation of the normal distribution is 3 kilograms. You are asked to find how many students masses. Mass means weight. You are asked to find how many students masses greater than 72 kilograms. If you want to find how many students masses greater than 72 kilograms, first of all, you need to find the probability of student mass greater than 72 kilograms. First of all, you need to find student mass greater than 72 kilograms. how many students masses greater than 72 kilograms. So first of all, you need to define x is equal to masses of the students, means weights of the students. Problem number 1. Actually, look here, how many students masses greater than 72 kilograms. If you want to find how many students weights greater than 72 kilograms, first of all, you have to find the probability of students weights greater than 72 kilograms. After that, we find how many students masses greater than 72 kilograms. First probability of student masses greater than 72 kilograms is needed. That's why we are finding x is equal to weights of the students or masses of the students. Problem number 1, probability of masses of the students greater than 72 kilograms. First, let me explain. Yes. Srujana, first, third one is correct. Please verify first and second. Let me explain first. We are finding probability of student masses greater than 72 kilograms. And everyone should listen to me carefully. Normal distribution problems can comfortably solved by converting into standardized normal random variable. What is standardized normal random variable? Any random variable that is subtracted from mean. X is a random variable. It is subtracted from mean and divided by standard deviation. So regarding normal distribution problems, first you need to convert into standard normal distribution. To convert into standard normal distribution, make x as x minus mu by sigma. X as x minus mu by sigma. Then it becomes z, called as standard normal random variable. So first you need to convert into standard normal distribution. To convert into standard normal distribution, make x as x minus mu by sigma. To make x as x minus mu by sigma, add minus mu both sides. X minus mu greater than 72 minus mu. And divide both sides by sigma. Divide both sides by sigma. X minus mu by sigma, you have already seen x minus mu by sigma is equal to z. Z is equal to x minus mu by sigma. That is called standard normal random variable. So x minus mu by sigma meant for z. So it is z greater than 72 minus 68 by sigma, that is 3. Now it should be P of z greater than 4 by 3, that is 1.33. 4 by 3 is 1.33. You need to use a standard normal distribution diagram. You have to use a standard. I am using standard normal distribution diagram because problem has been converted into standard normal distribution. That's why you need to use a standard normal distribution diagram. So this is z is equal to 0. and this is z is equal to 0 regarding standard normal distribution, and 1.33 will lie to the right side of origin. This is z is equal to 1.33. Z greater than 1.33 means area to the right side of 1.33. Z greater than 1.33 means area occupying to the right side of 1.33. This is the area to the right side of 1.33. Means from 1.33 to infinity this area will lie. But we don't know how much portion, what is the shaded area. How much area that shaded area, how much area this shaded portion occupied, we don't know. That's why we people know that total area to the right side of origin, that is to the right side of z is equal to 0 is 0.5. In that 0.5 area that is occupying to the right side of z is equal to 0. From that 0.5 area, I will subtract the blank area. That means 0.5 minus area occupying between z is equal to 0 and z is equal to 1.33. Total area to the right side of this vertical line is 0.5. From this 0.5 area, subtract this blank area, you will get this shaded portion. So therefore, 0.5 area, that should be total area to the right side. From that, you just need to subtract the blank area. Blank area is lying between z is equal to 0 and z is equal to 1.33. So 0.5 minus, in this statement of the question, it was clearly mentioned area under the normal curve between z is equal to 0 and z is equal to 1.33 is given to be 0.4082 is given to be 0.4082 given in the statement of the problem. P of 0 less than z less than 1.33 means area under the normal curve between z is equal to 0 and z is equal to 1.33 is 0.4082 given in the problem. So I will go to the next slide. So 1 minute. Answer 0.0918. That is correct. 0.0918. This is the probability of students' weights greater than 72 kilograms only. But we were not asked to find the probability of students' weights greater than 72 kilograms. We were asked to find how many students' weights greater than 72 kilograms. One student weight greater than 72 kilograms is 1 into probability of student weight greater than 72 kilograms. Two students' weights greater than 72 kilograms is 2 into probability of student weight greater than 72 kilograms. 300 students weights greater than 72 kilograms is 300 into probability of students weights greater than 72 kilograms. Right, next step. Therefore, expected number of students' masses greater than 72 kilograms is equal to 300 into 0.0918. What is the answer you found? Approximately 28. 27.5, make it as 28. Problem number 2. Problem number 2. Probability of students' weights less than or equal to 64 kilograms. 27.54, 100% correct, make it as 28. 27.54 correct only, but I have written approximate value. That is 27.54. Let it be approximately 28. Now, probability of, now convert the random variable capital X into Z. To convert the random variable into standardized normal random variable, make X as Z. To make X as Z, add minus mu both sides and then divide both sides by sigma. Because X minus mu by sigma will be Z. X minus mu by sigma is equal to Z, called as standard normal random variable. So Z less than 64 minus mu, that is 68, by sigma. What is sigma? 3. So this is probability of Z less than minus 4 by 3. Minus 4 by 3, that is minus 1.33. So draw the standard normal distribution diagram. Standard normal distribution diagram. So this is Z is equal to 0. Minus 1.33 will be on the left side of origin. So this is Z is equal to minus 1.33. So sketch this area. Do you know now? And listen to me carefully, everyone. Look here. Z greater than 1.33 means area lies between Z is equal to 1.33 and Z is equal to infinity. Be careful, everyone. Z greater than 1.33 means area between 1.33 and infinity. Area between 1.33 and infinity. Here Z less than minus 1.33 means area between minus infinity and minus 1.33. Whatever the distance between 1.33 and infinity, same distance will be there between minus infinity and minus 1.33. Therefore, normal distribution curve is a symmetrical curve. So that's why whatever the area occupying, symmetrical curve means interval length same, area same. So whatever the interval length lying between 1.33 and infinity, same interval length will be there between minus infinity and minus 1.33. Therefore, whatever the area occupying between 1.33 and infinity, same area will occupy between minus infinity and minus 1.33 by symmetry. So what is the area answer here? 0.0918. Area answer is 0.0918. How did I write? By still you have a doubt, step by step I will explain. If you have a doubt, step by step I will explain. Look here. This I can write it as the shaded area is equal to total area to the left side of origin. Total area to the left side of origin is 0.5. That 0.5 area minus blank area. Minus blank area lying between Z is equal to minus 1.33 and Z is equal to 0. So normal distribution curve is a symmetrical curve. So whatever the area occupying between minus 1.33 and 0, same area will occupy between Z is equal to 0 and 1.33. just because of symmetry property. Symmetry property means whatever the area between -1 and 0, same area between 0 and 1. Whatever the area between -1.33 and 0, same area will be there between 0 and 1.33. That's why I have written like this. So this is 0.5 minus area under the normal curve between z is equal to 0 and z is equal to 1.33 was given to be 0.4082. Therefore, P of x less than or equal to 64 is equal to 0.0918. This is the probability of students' weights less than or equal to 64 kilograms. Similarly, just like in the previous problem, expected number of students' masses So just 2 minutes, last problem will be completed. 2 lines only, last problem. What is that? Will you solve? Listen to me, all of you. Third problem, try yourself. Third problem, after simplifying, you will get P of, listen to me, third problem after simplifying, you will get P of -1 less than x less than 1. P of -1 less than x less than 1. P of -1 less than z less than 1 is area under the normal curve between -1 and 1. It's a property. When you solve the third problem, you will get P of -1 less than z less than 1. Means area under the normal curve between -1 and 1 is 0.6827. These three values will not be given in the examination. You only have to remember and write. When you solve the third problem, you will get P of -1 less than z less than 1. Then replace it by 0.6827. Yes, last problem answer 205. Last problem answer 205. You have a doubt? Just 2 minutes. Look. I'll stop in 2 minutes. Wait for 2 minutes. I'll start the doubt session. Both inclusive means that is what I am saying. Area under the normal curve between -1 and +1 is already given 0.6827. Right? 300 into 0.6827. That's it completed. Now let us start doubt session. 205 started doubt session. I'll talk to the students. Prashant. First Prashant, followed by Harsha, followed by Sai Mohan. This is the sequence. Prashant, do you hear me?
Yes, sir. Good morning.
Can you hear? Good afternoon. Tell me.
Good afternoon. Sir, for this question, why we are going for the standard deviation? Because like
fine. I will explain. What is the purpose of converting into standard normal distribution, right?
Yes, sir.
1 minute. Listen to me. The first problem, P of x greater than 72, correct?
Yes.
Look here, P of x greater than 72. Any number greater than 72 should lie between, any number greater than 72 should lie between 72 and infinity.
Yes, sir.
Now, do you know probability density function third condition? P of a less than x less than b. That is integral a to b f of x dx. Probability density function third condition.
Yes.
Look here, 7 P of a less than x less than b integral a to b f of x dx. And look here, f of x means what?
F of x is
Probability density function of standard
Sigma.
normal distribution. Probability density function of standard normal distribution, right?
Okay, sir.
So what is sigma value we were given? 3. Standard normal distribution. Mean how much? 68. Mu means 68. Sigma value 3. You only tell me. To solve this integral, again you need to assume x minus 68 by 3 is equal to t. And again it will be converted to t. And again you need to solve this integral. It will consume a lot of time. You only observe. This is comfortable. Solving this problem, this is comfortable. Even I have written 4 steps. Problem not yet completed. You need to assume x minus 68 by 3 is equal to t. It will be converted to new integral. And again it should be solved. After simplifying, you will get whatever the answer I gave here. You will get this 0.0918 answer.
Okay. So one more doubt is whether this can be converted like 1 minus probability of x greater than 7.
Yes, 100% correct.
So that would be much simpler. Is if it whether it is simpler.
Which see, I have just one problem I solved as per the procedure in the examination. Whichever you feel comfortable, that is 100% correct. You can adopt that, no issue.
Okay, sir. One more doubt is.
Ask me.
How this is considered? Okay, it is mentioned as normal distribution, so we are taking under continuous.
In the examination, they will mention normal distribution, they will mention uniform distribution, they will mention exponential distribution. Sometimes Poisson they will mention, sometimes Poisson they will not mention, but binomial will never be mentioned. You have to remember 4 conditions and solve accordingly.
Okay, sir. And one more question on problems on independent events. The last class. That the P of...
1 minute. A and B are independent events. P of A intersection B is equal to P of A into P of B. Right?
Okay, sir.
Suppose I am assuming A and B are independent events. Then P of A intersection B is P of A into P of B. Okay, na?
Okay, sir.
Now, suppose A and B are mutually exclusive. If A and B are mutually exclusive, P of A intersection B value 0. This is what you are asking?
Yes, sir.
Clarity between independent and exclusive now you want?
This is okay, sir. And one more thing, one more question on let E and F be any 2 events. P of E is 0.4, P of F 0.3. And P of F, given that E is equal to 3 times the P of F.
That problem I taught on that day itself. Other students are also waiting. If you can wait for 5 minutes, that problem solution I will give you.
Okay, sir, I will wait.
1 minute. Venkat Cheppu. అవి లీనియర్ ఆల్జీబ్రా చేయాలి అంతే కదా అలా వెంకట్ okay. Students, tomorrow you have linear algebra schedule. Please inform to your friends also. Tomorrow linear algebra, Monday onwards, technical session will start. Prashant, please stay on the line. I will tell you. Next, I will talk to Harsha. Harsha, tell me.
Can you hear me, sir?
Yes, it's audible. Tell me.
Sir, in this last question, I did not understand the first step, sir.
In the last question, this one,
Yes, sir.
What they mentioned, look here. Look there. Students' weights lying between 65 and 71. X value lies between 65 and 71 will be written as 65 less than X less than 71.
Sir, just 1 minute, sir. Sir, in first part, greater than 72.
Fine.
The first point, x minus mu upon sigma.
That 1 minute, 1 minute.
Okay, sir.
To actually regarding normal distribution, it is better to convert it to standard normal distribution. Standard normal distribution means what? Z is equal to x minus mu by sigma is called standard normal random variable.
Yes, sir. Hello?
Standard normal random variable. That's why I converted into standard normal random variable.
So, sir, why you take greater than, like, which condition x minus mu upon sigma greater than 72 minus mu?
What standard normal random variable is x minus mu by sigma. That's why make x as x minus mu by sigma. To make x as x minus mu by sigma, add minus mu. First to x greater than 72, add minus mu both sides, and then divide both sides by sigma.
Okay, sir. Got it, sir. And sir, one more question. In one previous question, there is something like a cumulative distribution function. So what is that, sir?
Cumulative distribution did not we cover?
Sir, I actually not remember, sir.
Okay, no issue. Tomorrow I will teach in the class only.
Okay, sir. Thank you, sir. Over, sir. My out is over, sir.
Okay. You unmute yourself.
Thank you, sir.
Yes, sir.
Prashant, tell me.
Sir, Mohan, sir.
Tell me.
Sir, in the last question, for the question went greater than 72. The number of students we got are 28, right, sir? Like if we add the number of students for all the three cases, shouldn't we get 300, sir?
Which one? Answers, sir?
Yes, sir.
No, actually these are the averages. No, how averages will be added?
Okay, sir.
I said, look there, expected means average number of student masses greater than 72. This is average.
Okay, sir.
Average, not if it is exact, directly we can add. It is expected means average number of students masses.
Okay, sir. Thank you, sir.
Next, Anshul. Anshul.
Yes, sir. Can you hear me, sir?
Yes.
Yes, sir. Actually, I asked that I need your number, sir. Phone number.
No doubt. 94900200373.
20373. 94900200373. Is that okay, sir?
Okay.
Sir, another thing, sir. You told that from tomorrow linear algebra is going to start.
No. Actually, probability has to be completed. They don't know the schedule. That's why they might have mentioned like that. Actually, I forgot. Tomorrow, probability only.
Until this probability completes, linear algebra won't start, no, sir, mostly?
Yes, linear algebra will start.
And how many days it will require to complete this probability, sir, more?
Tomorrow I will be going to finish.
How many concepts are there other than
uniform exponential statistics.
and cumulative is not yet explained, no, sir, actually?
No. Tomorrow I forgot. Tomorrow I will teach in the class only. Okay, na?
Okay, sir.
Rahul Mishra.
Hello, sir.
Tell me, Rahul Mishra.
Sir, in the last question, they asked greater than 72, no?
Okay, 1 minute. Venkat asalu marchipoyam repu probability undi kada. లేదు రేపు వరకు ఇచ్చావు కదా షెడ్యూల్. రేపటి వరకు ఇచ్చావు కదా షెడ్యూల్. అది కాక చూడు. Tell me, Prashant.
Sir, in the last question, they told to find the number of students greater than 72. Does the answer remain same if it's like greater than or equal to 72?
See, it is greater than for continuous random variable, greater than or equal to, less than or equal to, no issue. For all continuous random variables, it is greater than 72, greater than or equal to 72, same answer only you get.
Okay, sir. Okay, sir.
That's it, huh?
Okay, thank you, sir.
Okay. Prashant?
Sir, the question.
Tell me the question.
Let E and F be any two events with P of E is equal to 0.4, 0.4, P of F is equal to 0.3, and P of F given E is equal to 3 times P of F given E complement. Find.
Okay, look here. Look here. Did you see the information I have written?
Yes, sir, I could see that.
I am writing the steps. You just observe. If you can't understand, ask me. Okay. Okay now.
Okay.
P of E intersection F by P of E is equal to 3 into E complement intersection F. E complement intersection F means what?
E complement is F.
F minus E intersection F, right?
Yes, sir.
Understood?
Yes, sir.
Understood or not?
Yes, sir, understood.
So P of E complement, and look here, P of E intersection F don't know, and P of E 0.3, 3 into inside the bracket, P of F given 0.3 minus P of E intersection F don't know, right?
Yes, sir.
By P of E complement 0.6.
Yes, sir.
Actually,
E
3 times
is 1 minus, okay, 0.4.
1 minus 0.4.
Yes, sir.
Actually, you are giving the wrong information. It is, I said 3 times. 1 minute. E, is it F given E complement?
Yes, sir, F given E complement 3 times of.
F given E complement. F given E complement. So F given E complement, and the remaining area, that is P of F minus P of E intersection F, right?
Yes, sir.
P of E intersection F by P of E 0.4, P of E complement 0.6. Okay, fine. Look there, P of E intersection F is equal to 0.4, will go right side, 3 into 0.4, 1.2 by 0.6.
Yes, sir.
1.2 by 0.6, 2, right?
Yes, sir.
2 into P of F minus P of E intersection F, right?
Yes, sir.
So P of E intersection F is equal to 2 into P of F minus 2 into P of E intersection F, right?
Yes, yes, sir.
Minus 2 into P of E intersection F, if it goes to right side, plus 3 into P of E intersection F is equal to 2 into P of F. So this is P of E intersection F by P of F is equal to 2 by 3.
Okay, sir.
2 by 3 means 0.67. P of E intersection F by P of E, that is P of E given F only.
Yeah, that is what P of E given F is divided by P of F. Yeah, it's correct.
Understood?
Yes, sir.
Okay.
And one more question is, so how is P of F union E complement is drawn?
A union B complement,
Yes, sir.
A union B complement means complete A will be chosen. Complete A will be chosen and outside area. Complete A will be chosen and outside area.
So it is equal to P of A.
No. A union B complement. A complete A B complement means complete B outside area is also there. A union B complement means this outside area.
So
this what is this? A union B complement means complete A plus this outside area is A complement intersection B complement. that is A plus A union B whole complement. Outside area, this outside two circles area is also there.
Oh, okay. Okay, sir. That is okay.
Otherwise, I will explain. Some other students are also there.
Okay, sir. Okay, sir. Yeah. Thank you, sir.
Fine. Sahiti.
Am I audible?
Yes, audible. Just
So,
1 minute.
yes, sir.
Tell me. Tell me.
So, in normal distribution,
Hmm.
so can you explain that first term once again? I didn't understand.
Okay. This one. What is the question?
No,
How
sir.
many?
No, sir. No, sir. No, sir.
This one.
First one.
This one,
Probability 100 less than x less
this
than
one,
1. Yes, sir. I didn't understand the graph.
Look there. What is the mean of the normal distribution? 100.
Yes, sir.
So this is x is equal to mu. What is this? 100.
Mu.
100.
Yes, sir.
Okay.
100.
And we were given probability of x value lying between 100 and 120 is 0.3. Correct?
Yes, sir.
This is 100. 120 means 20 units right side.
Yes, sir.
So that is 0.3. Okay, na?
Yes, sir.
So total area to the right side of x is equal to mu is
0.5. Yes, sir.
It is already occupied 0.3. So remaining
Yes.
area 0.2. Okay, na?
0.2. Yes, sir.
And you are asked to find the probability of x less than 80. This is
80.
100. 80 means 20 units left side.
20. Okay, so this side also you'll consider as 0.3.
Because the distance between 100 and 120, 20 units. So
20 units.
the distance between 80 and 100 also 20 units. So because of
Yes.
symmetry, same area.
Yes, sir.
Okay,
Understood, sir. So even the second question.
the second question you are asked to solve. If you draw the diagram, same
Okay.
type of, no need to solve, same type of diagram. Once you draw the diagram, the way you have drawn, you will get the
Yes.
answer. Only diagram, no answer.
Okay, sir. Thank you, sir.
100% similar, unable to solve, I will explain.
Okay, sir.
Will you try?
Yes, sir. I'll try.
Okay, fine. So students, I am going to end the meeting.
అలాంటప్పుడు యూజువల్గా మనం రెగ్యులర్ పేపరే చూస్తామండి. అంతే కదా. అవును చెప్పారు కదా మీరు నాకు రామస్థాయి వచ్చినప్పుడు మీకు చెప్పారు. సెషన్ మధ్యలో మాట్లాడతాను.